Welcome back, everyone. Patrick here, moving on to another question dealing with quadratics. Very similar to the previous two videos where we're given a graph, we're going to have to find the equation of each of these parabolas in standard form. So when I'm going through this, I'm assuming that you've watched those previous two videos. And if you're watching this on YouTube, you could find the website in the course description. There's a link where everything follows in order. And you should follow it in order because there's always carryover as the videos go on. So over here, same sort of deal. Notice that we're given intercepts for the parabolas here. So what we're going to have to do is we're going to have to get these parabolas first in factored form because we're given those intercepts. So from the intercepts, we can get the factors. And then we can use the other point on the parabola to solve for that a value. And then once we have that, we can expand everything and then get it in that standard form, y equals ax squared plus bx plus c. Now, in this particular case, it's going to be a little bit more tricky because we're actually going to be dealing with intercepts that are fractions. Before we were dealing with integers, now we're dealing with fractions, and we've done this before where we're given intercepts or the roots and we have to find equations. Now it's just in a diagram. And if you remember, let's pretend that, let's just bring in a random quadratic, so something like, let's put an a value here, -2, we got 3x minus 2, and let's say we got like 5x plus 3, like that. How do we find the intercepts of a quadratic that's like this? Well, we find when does 3x minus 2 equal 0, and then over here we find out when does 5x plus 3 equal 0. So this is going to happen when 3x is 2, which is when x is 2 over 3. This here is going to happen when 5x is -3, when x is -3 over 5, right? So just standard finding these sort of fraction intercepts. So now we're given these fractions here, and we're going to have to go backwards. So we're going to have to find these factors here. So we're going to have to go from here to here. Okay, and the way you could do that, let me just show you with this example that we just did. If we're given x equals 2 over 3, what you can do, and as I've done in previous videos, is we just cross multiply. So we go 3 times x, which is 3x, 1 times 2, which gives us 2. Bring the 2 over. We end up with 3x minus 2 equals 0 over here, which means 3x minus 2 is the factor. So same process with these fraction exponents that we're going to be dealing with. So let's start off with this -9 over 5. So we have x equals -9 over 5. Put this over 1. Cross multiply. 5x equals -9. Bring the -9 over. We end up with 5x plus 9 equals 0. So 5x plus 9 is the factor from where we get the intercept of -9 over 5. That's how you go backwards. So with the 4 over 3, same thing, put the x over 1. 3 times x gives us 3x. 1 times 4 gives us 4. Bring the 4 over. 3x minus 4 is equal to 0. So that would be the factor for that corresponding x-intercept. Right, so now we have the factors. So that's the only difference really, is that there's a little bit more work now in finding these factors, but it's still not bad at all. Actually, there's going to be a little bit more work to find the a value because there's going to be some multiplication we've got to do when we plug in this point. But again, it's not going to be a huge deal. Let me just make sure that we're all good here. Yes, looks fine to me. So now what we could do, plug in this point for the x and y. So we got -28 over here. We got a 5 times 1 plus 9. 3 times 5 minus 4. So this would be 5 times 1 is 5, plus 9 gives us 14. 3 times 5, wait, where did I get the 5? Sorry, I got confused there. There should be a 1 over here, right? We're plugging in 1 for x. I don't know where I got this 5. Maybe I was thinking of this 5 over here. But we're plugging in 1 for the x values. We're plugging in -28 for the y value. So 3 times 1 is 3 minus 4 gives us -1, -28. So we end up with -28 equaling -14a right? When we multiply all of these, divide both sides by negative 14, a value is 2. Yeah, so the a value is 2. Plug in 2 over here, and now to get it in standard form, what we got to do is just expand everything. So we have y equals 2. 5x times 3x gives us 15x squared. 5x times negative 4, negative 20x. Positive 27x minus 36. And then we end up with this here would net out to 7x minus 36, like that. And so when we expand everything, give me a sec, yeah, expand the 2 inside the bracket, we end up with y equaling 30x squared plus 14x minus 72, like that. All right, so this here is the standard form quadratic for this over here. And if you want to, again, check your answer, you could plug in the x values for all of these points here and just make sure you get the corresponding y values. And that's how you could check that this solution would be correct. And if you did that with these points, you would see that it is correct. So then moving on to part B, let's actually erase this first graph just to give myself some room here. So again, we're going to get this, because we have the 2 intercepts there, we're going to first get this in factored form. So we got the 2 intercepts, x equals 4 over 3, which is actually one of the same intercepts that we had in part A, which is nice. But let's go through the process one more time, just some repetition. Cross multiply, 3x minus 4 is equal to 0. So that would be the factor there. For the intercept of 9 over 2, 2 times x, 2x, 1 times 9 is 9, bring the 9 over, 2x minus 9 is equal to 0. So that would be the other factor. So we plug in these factors over here, and then we could plug in that point for negative 16 over 3 to solve for the a value. So we have negative 16 over 3. We're going to have a fraction here, but let's see what we end up with these brackets. So we'd have 3 times 4 minus 4. Plugging in 4, right, for the x values. Let's not make a mistake this time. Like that. So we end up with a. 3 times 4, 12 minus 4 is 8. 8 minus 9, negative 1. So we end up with negative 16 over 3 equaling this. Multiply everything. A times 8 times negative 1 gives us negative 8a. And from here, multiple ways to isolate for this a value. Because we have a fraction here, we can multiply both sides by 3 to get rid of this denominator. I'm going to just put this over 1 and then cross multiply. 1 times negative 16 is negative 16. 3 times negative 8a is negative 24a. So we end up with, if we divide both sides by negative 24, we end up with a equaling negative 16 over negative 24. So notice the negatives cancel out. 16 over 24, that would be what? 2 over 3, right? We could divide both the numerator and denominator by 8. And so the a value is 2 over 3. One thing I didn't mention either, notice that the a value is positive. Makes sense because the parabola is opening up. If it was opening down, then we should get a negative a value. Okay, so we end up with, let's just quickly double check the work here. And it looks all good to me. So we end up with 2 over 3. Yes, looks fine to me. So now what we do, take that 2 over 3, plug it in here, and we got to expand everything. So this is the factored form of this quadratic. If we expand everything, we'd end up with 6x squared, negative 27x minus 8x minus positive 36 rather. Negative 4 times negative 9 is positive 36. And then from here, 2 over 3. 6x squared minus 35x plus 36, like that. So then we could just multiply this 2 over 3 by everything. So just be careful with the algebra here. 2 over 3 times 6 would give us 4x squared. 2 over 3 times negative 35 would give us negative 70 over 3. And then we got the x here. 36 times 2 over 3 would give us 24, positive 24. Okay, so that right there ends up being the final answer. Okay, so when you're dealing with these fractions, just be careful not only in terms of getting the intercepts or getting these factors, but also if you have like an a value that's a fraction when you're expanding everything. Things can get a little bit more complex, but nevertheless, that's the standard form quadratic for this parabola.